Good morning, Sevens. So I'm going to have two videos that I'm going to post today. I decided to make this change. This is the first video where I'm going to describe the heart of what this lesson is about. And then I'm going to make a second video talking through your guys' assignment. Should be here. Yeah, talking through your guys' assignment and like, what does all this verbiage mean? Can we walk through and just break down what this is asking you to do? And then you should be able to do it. I'm thinking it should make it easier for people, like if you get all the way through down to here and then you're stuck because this doesn't make sense. Well, this shouldn't because it's just drawing dot plots. But you'll hit things that are really complex the way they're stated. And if you get stuck in it, come back to the second video and it'll show you how to deal with that. But in the first video, I want to show you what we're dealing with today. So we've been talking about this idea of sampling variability. And I wanted to give just a description of what we mean. So we have a population. The population is every data point under this black curve. We could think of this as income distribution. That's what I was thinking for people in Latvia, but most income distributions look like this, where we have a lot of people who make very little money and a few people who make a lot of money, and then we kind of have this just curve that connects all the people between. And so this is a normal income distribution, and the population would be every single person in this income distribution. If we're talking about income of Latvians, it is every Latvian in the whole country. The population X bar, or the population mean, is the actual average, which we want to find. Usually we don't know this. Sometimes we can't find it, and we have to be able to say, like, are our approximations good, or how good are the approximations? Because we can't find the actual population mean, or X bar. So that population mean is here in black, and I'm going to continue with that. Then we have samples. The sample is selected points. We usually select them randomly in order to try to represent the population well. So here I have some red dots that we've chosen. Those are my sample. And then the sample X bar, the sample mean, is the average of the sample points, which is intended to approximate the population mean, or the population X bar. So our sample, given this, it's pretty well distributed. It was randomly. We had some people who are pretty wealthy, some people that weren't, a lot of people in the middle. And because of that, this sample mean is very close to the population mean that's in black. So the problem arises, based on a random sample, we could get very good samples or we could get very bad samples. And so the question is, how can we determine, how can we know if we have a good sample or a bad sample describing this? And here I'm just showing some examples. This is the same income distribution, the same population mean is in black. But if I randomly chose these points, I would get a very bad sample mean. It would not approximate this population mean. And so that would look like, in this case, look like Latvians are very, very poor people. Or if we chose these people out here, then it would look like Latvians are very, very rich people. The problem is we want to convey the truth. So we want some sort of sample. We want to be able to test and see, does our sample actually describe the population? And we have to be able to test that while we don't know the actual population descriptors. So because of that, we have these ideas of variation, and we have to be able to decide. And that's what you were doing in the last lesson, really. You were looking at the boys and the girls and saying that they're one mean absolute deviation away from each other. The averages are one mean absolute deviation away, and so that's not significantly different. In this lesson, we set you up saying 2 mean absolute deviations is enough to be significantly different. 2 means is a difference that is greater than would have been expected. So yesterday, that's just saying if the boys, I should have had this, if the boys' mean was 35 and the girls' mean was 39, and both of them had, boys' mean absolute deviation was 4, and the girls' was also 4, then these are one mean absolute deviation away from each other. Just saying, 35 plus 4 is 39. Well, this 4 right here, that 4 is 1 mean absolute deviation. Just saying those mean absolute deviations are 4. When we would say, according to this rule, when we would say there's a meaningful difference between 2 means, is when it's greater, when the means are two mean absolute deviations difference. Where does it say this? It says it somewhere in here. So if this were 35, come on, if it were 35 plus 4 plus 4 for two mean absolute deviations, and that was 43, then we would say, like, if the girl's mean was not 39, but instead was 43, then we would say these are significantly different. So we would have sampling things going on. Or in this case, it would mean these two populations are significantly different in the way they attack the problems. I'm probably talking too much. Best of luck. Go for it, sevens. Talk to you soon.